right, we have made it to video 5, and I don't even know if I've said UCS yet. This is a UCS course, so let's talk about UCS. We've now learned and have a good idea of how iSCSI and fiber channel over Ethernet work, and so now we need to apply that into our UCS space. Let's dive in and make this happen. So as we relate this back to UCS, we recall that we've got a pair of fabric interconnects, and these fabric interconnects are going to connect down via the I/O modules, and those I/O modules will connect down to each physical server. Now this physical server, in most cases, especially in a chassis environment, this is going to house Cisco's virtual interface card, otherwise known as the VIC. And these IOMs are going to connect into the VIC from a physical perspective, and then the VIC will extend virtual connections downstream to the hypervisor. So let's get that in the picture here. Let's draw our hypervisor in a different color so we can see it. This would be our hypervisor, and inside the hypervisor, we know that we've got vSwitches. And what the VIC is going to do is it's going to extend virtual NICs into the hypervisor space. So the hypervisor thinks these are physical NICs. We know that they're virtual NICs. And then each one of these will connect into, let's just say, this vSwitch here. So let's start talking about iSCSI. iSCSI is pretty interesting because it's already TCP/IP traffic. And so the question is, do we need to configure anything special in UCS in order to make iSCSI happen? And the answer is, believe it or not, no. iSCSI is already going to work. It's going to work without us getting involved. The closest thing we need to do is make sure all of our settings are tuned properly. So we want to make sure our MTU, for example, is set to 9000. We want to make sure our COS tags are in place, and there is no official default COS tag for iSCSI, so you might deploy it with a tag of 4, you might deploy it with a tag of 2. But at the same time, these are going to use traditional virtual NICs. So what I've drawn here, these are no different than any other virtual NIC, again, other than the local configuration that we might want to apply. But they will show up in the hypervisor just like any of these other vNICs, and so we'll need to make sure that we're associating them with the appropriate virtual switch. Now, it's not at all uncommon inside of our hypervisor to have a dedicated virtual switch. This dedicated virtual switch is going to do pretty much what all of our different virtual switches are doing, which is to segment off the traffic that we're dedicating that switch for. Now, in most cases, iSCSI is going to make use of what we call a VMK. That would be a VM kernel port, and effectively equates with an IP address that exists inside of the hypervisor. The hypervisor wants to form a TCP/IP connection out to the storage wherever the storage might be. Now in our iSCSI space, we tend to keep this in a layer 2 fashion. We don't want to route iSCSI because then we lose our layer 2 MTU. I've actually helped troubleshoot environments where we are accidentally routing our iSCSI traffic, and because of that, it was causing all kinds of CPU issues in the environment because we had our jumbo frames configured properly, but then we were routing them, meaning that we had to fragment these packets. There's a lot of fragmentation and defragmentation happening on the network, and so let's make sure that we don't accidentally route our iSCSI traffic. Now, if we're not routing it, then we can probably assume, safely, that the virtual NICs that we're deploying must be on the same VLAN as our upstream storage array. So that is something we'd want to consider. Now, one last note I'll make about iSCSI is that if you look inside of UCS Manager, you will see something called an iSCSI vNIC. Let's not get confused by the iSCSI vNIC because that is dedicated for what we call iSCSI boot. We're going to cover this in more detail in the next video. But the iSCSI vNIC is not the type of vNIC that we deploy down to our iSCSI connections, and that is the takeaway that I want you to know. So let's clean up our drawing here, and now we're going to talk about fiber channel. In most cases, our fabric interconnects are going to support native fiber channel connectivity. Native fiber channel connectivity happens via what we call unified ports, or UPs, and the unified ports allow us to convert an Ethernet interface into a fiber channel interface. However, something to realize about fiber channel is that it is always in the SFP form factor, meaning that this must be an SFP plus or possibly an SFP28 interface. So we recall that there's a 6300 model of fabric interconnect that is only QSFP driven. Well, we can't support native fiber channel on that because we don't have the right form factor. So we need to check and make sure that the fabric interconnect we want to deploy, if we want it to support native fiber channel, that FI needs to support unified ports. Now remember that fiber channel is always deployed with different distinct fabrics. And so fabric interconnects are actually designed around that a little bit. This idea that we have two distinct fabric interconnects allows us to connect up to our distinct SANs. So we'll have storage area networking A, and we'll have our storage area networking B fabrics connecting into the respective FIs. Now incidentally, fiber channel over Ethernet is also fully supported on these fabric interconnects, meaning that I might have an FCOE connection up to the respective storage area networks, but beyond that, we are going to make all of these connections downstream of the fabric interconnect support FCOE. That means that whether I'm running native FC or I'm running FCOE, it doesn't matter. Either way, that traffic is going to get mapped down to the FCOE connections. The fact that we support FCOE in this domain down here is meant to simplify our UCS cabling environment. We would never cable native FC connections down to the I/O modules because as much as anything, the I/O modules wouldn't support it. But also that would increase the amount of cabling that we have to do, or maybe we have to cable the fabric interconnects down to the VICs directly. This would be a nightmare. But fortunately for us, Cisco just made it FCOE everywhere, and now we don't have to worry about it. So now let's talk connectivity, because this VIC is known as what we call a converged network adapter, otherwise known as a CNA. Remember, we have NICs for Ethernet and we have HBAs for fiber channel. A converged network adapter is capable of both. It's capable of doing fiber channel over Ethernet. And in most cases, whether it's with UCS or not UCS, the CNA is going to present itself to the operating system and to the hypervisor as if it's a NIC and it's an HBA. The operating system or the hypervisor is going to see those as separate entities, and that's all handled by the firmware of the CNA itself. Now, our VIC we know is special. It's going to go a step further than simply presenting itself as a NIC and an HBA. We know that we can configure as many VNICs as we want. And technically speaking, we can configure as many virtual HBAs as well. Now, that said, for the most part, we only need 2 of these. We need one dedicated for Fabric A, and we need one dedicated for Fabric B. So in our environment here, we're going to spin up 2 different virtual HBAs. Those looks a little bit different than our VNIC environment. And now the hypervisor down here, it's going to see that I have attachment. I have attachment to one of the fabrics, we'll say this is Fabric A, via the VHBA on the left, and I have a connection to Fabric B on the other side. And now I've got my distinct fabrics all the way up to the storage array that is itself somewhere in the middle here connected to both SAN A and SAN B all at the same time. Now you may recall that we have the concept of a VNIC that attaches to a virtual Ethernet interface. And that virtual Ethernet interface lives inside of the fabric interconnects. Well, we have a very similar concept on the fiber channel side of things because we have virtual HBAs that connect to virtual fiber channel interfaces, otherwise known as VFCs. As such, I'm going to have a VFC on Fabric Interconnect A, and I'm going to have a VFC on Fabric Interconnect B. And this VFC is going to form the connection down to this VHBA. In the same way that I apply configuration to the VETH port, for example, quality of service and VLAN trunking information and such, any traditional fiber channel configuration is also going to go onto the VFC interfaces. And so we see a lot of parallels between what we've already covered with VNICs and how VHBAs are deployed. Now that said, there is one thing that the VNICs can do that the VHBAs cannot do, and that is the concept of fabric failover. We can't leverage fabric failover in fiber channel world because our fabrics are distinct. There's no way that my VHBA can actually fail over to this side and give me good results. Because remember, I'm connecting to Fabric A via this virtual HBA, and I can't swing that over to Fabric B and have 2 different connections to Fabric B. This is why we traditionally deploy 2 VHBAs, and I'm going to dare say that we almost always do and should deploy 2 VHBAs because we can't take advantage of fabric failover. So I will erase the fact that we've got a dotted line there just so that our drawing is good and complete. And so again, while we see the parallels between the VNICs and the VHBAs, the Ethernet and the fiber channel world, we also see how the fiber channel traffic must be treated a little bit differently in this framework. So we started this conversation by talking about iSCSI, and iSCSI is just like any other TCP/IP traffic flow in UCS. We don't need to treat it special per se, although we do need to make sure that our VNICs, and again, they're standard VNICs that we deploy down into our hypervisor, that those are configured for standard iSCSI configurations like jumbo frames and class of service and such. Now, as far as fiber channel is concerned, we did have a little bit to learn here. The fiber channel traffic as it comes into the fabric interconnects upstream, that can be native fiber channel. We saw how we can do that with unified ports when we have that available to us in our hardware, but we can also terminate not native fiber channel over Ethernet connections. Now, downstream of the fabric interconnects, we have those virtual HBAs that the VIC is capable of creating. So we can create technically as many as we want. We should probably just create 2, one for Fabric A and one for Fabric B, and that will be presented to the operating system or the hypervisor. And those are going to connect back up to virtual fiber channel interfaces. So in the UCS world, when we're talking about this kind of thing, we've got VETH ports, we've got VFCs, and that's all part of how UCS does its networking. I hope this has been informative for you. I'd like to thank you for viewing.